Yes, dear students, in last previous video I told you the definition of friction and then type of friction, cause of friction, etc. Here I take kinetic friction or dynamic friction. I told you two type friction, static and dynamic or kinetic. Static friction between two surfaces act when they are rest and body tries to move, and value of static friction vary from 0 to certain maximum value, and that maximum value of kinetic friction, maximum value of static friction is called limiting friction. And I plot a graph also between dynamic friction and applied force. It is force applied, and to that graph I like this, and this graph indicates that this is the value of limiting friction, which is more than kinetic friction. So I take kinetic or dynamic friction. For save time, to save time, I have written here kinetic friction is of two types, very popularly named known as number one sliding friction or slip करना, slipping friction, and number two rolling friction. पहला है स्लाइडिंग फ्रिक्शन, दूसरा रोलिंग फ्रिक्शन. तो स्लाइडिंग और स्लिपिंग फ्रिक्शन, when one body slides over or slips on the other surface, on the surface of other, then force of friction between the two surfaces is called स्लिपिंग और स्लाइडिंग फ्रिक्शन. सिंपल बात है भाई, अगर ये डस्टर इस पर स्लिप कर रहा है तो इसके बीच में स्लाइडिंग फ्रिक्शन है. एंड इफ दिस पेन रोल हियर, ये रोल करता है तो रोलिंग फ्रिक्शन. ये नहीं करेगा रोल क्योंकि इसमें डिस्टर्बेंस है, ये रोल करता है ऐसे, ये रोलिंग फ्रिक्शन. तो व्हेन वन बॉडी रोल्स ओवर द सरफेस ऑफ अदर, then the friction between the two is called rolling friction. It is very important to know here that sliding friction or slipping friction is very much greater than that of rolling friction. स्लाइडिंग फ्रिक्शन जो है वो बहुत ज़्यादा होता है, रोलिंग छोटा होता है. रोलिंग फ्रिक्शन actually initially this fact was not known to people, so we used to slip the loads, but in one accident a log of wood was placed somewhere in inclined plane like this, so that start rolling itself, and it was found that it is very simple, very easy to roll. To then wheel was discovered. Actually, when every vehicle is on wheel, तो wheel roll करते हैं on the road or on any surface, so that rolling friction is very small. In coming topics we will learn too much about sliding friction, rolling friction. Actually in one sentence you will learn कि during perfect rolling rolling friction 0, but even then rolling things are stop also, क्योंकि perfect rolling उनका perfect rolling होता ही नहीं. when a wheel rolls on the surface of, तो the surface get, ये ऐसा था ना, ये थोड़ा दब जाता है, ये ऐसे, ये जो सरफेस लोड होगी तब जाएगी व्हील की लोड से, क्योंकि प्रेस करता है नीचे की ओर. एंड हेंस ए वॉइड इज क्रिएटेड टू ब्रिंग द व्हील आउट ऑफ द वॉइड. वी नीड सम एक्स्ट्रा फोर्स विच विल बी इक्वल टू रोलिंग फ्रिक्शन. बट इफ परफेक्ट रोलिंग, आप इस बात को बहुत ध्यान सुने, प्लीज लिसन इट केयरफुली. ड्यूरिंग परफेक्ट रोलिंग फोर्स ऑफ फ्रिक्शन 0. खूब पूछते हैं इस बात को. In one chapter, when we learn rotational motion, I will explain you how perfect rolling takes place. But here on roads, when when we load sufficiently large load on any trolley, then becomes difficult to pull that, to roll that. Why? Because increasing the load creates void here, and to bring the wheel out, some extra force is needed. So that is rolling friction. In one seminar, actually we were attending a seminar on this topic, rolling motion, rotational motion. And I asked Professor, जो रिसोर्स पर्सन थे, कि रोलिंग फ्रिक्शन में when perfect rolling take place, no friction acts. But I asked, then why rolling body stops? So I could not get proper answer. Then I read the books again and again, and I got that during rolling, actually perfect rolling, perfect rolling कब होगा? When the road is perfectly elastic, means it does not deviate, it does not get a void here. It remains straight and wheel perfectly elastic. Wheel be perfectly elastic हो or road be perfect, then only possible perfect rolling. But nothing is perfectly elastic. There is a confusion about elasticity. Elasticity is a property of material which opposes any change in shape or size. If a body is perfectly elastic, then we say there will occur no deformation under any big force. तो वो perfectly elastic होगी. तो perfect elastic कोई नहीं होता, इसलिए perfect rolling होता ही नहीं. मतलब आइडिया है, कंसेप्ट है. Now I come here. There is a term and called angle of friction. आपको सब बुक में जगह नहीं है angle of friction का. Angle of repose तो written there, but angle of friction is not there. Angle of friction. So in one book I have read this, a famous book published by Nagin Prakash and Kumar Mittal Newton Physics. वहाँ पर एंगल ऑफ फ्रिक्शन को समझाने की कोशिश की, एंगल ऑफ फ्रिक्शन, एंड इट इज वेरी इंपॉर्टेंट टू अंडरस्टैंड. अगर कोई सरफेस परफेक्टली स्मूथ होगी तो फोर्स ऑफ फ्रिक्शन जीरो होगा. तो वहां पर हम समझेंगे, यहाँ पर इट इज एनी रफ सरफेस and here is a block. The weight mg of the block at downward, weight mg. So this surface is pushed by the weight of block downward. Reactionary force will act exactly in direction, that will have same line of action. लेकिन for some reason of creativity we feel like this. So when this is placed here, block placed here, two forces are there, mg weight of the block and p reactionary force. Actually मैं बता रहा हूँ कि इनकी लाइन ऑफ एक्शन सेम ही होती है, mg डाउनवर्ड एंड रिएक्शनरी फोर्स अपवर्ड. p लिखा है जानबूझ करके हमने यहाँ. But when we apply a small force on the block, इस ब्लॉक को हम पुल करते हैं by small force. You know, we represent arrow. We represent vector by arrow with the line carrying an arrow. Length of line represent magnitude, arrow की direction. तो ये मैंने छोटी लाइन बनाई just to show small force. Then weight mg will be acting downward. ये तो हमेशा नीचे रहेगा. But this reactionary force will get inclined away. P Now it may have two components. One along normal to surface. This is angle theta here, and this normal component may be called as reaction, normal reaction, R, or some people write it as N. And other component along surface. This is the static force of friction. Since the block is in equilibrium, this block is in equilibrium. So vector sum of F are Fp and mg. F plus mg plus p. इनका सम 0 रहेगा. It is at rest. It is in equilibrium. It is the force of friction. This normal reaction, part of this normal, part of the reaction is force P. One along normal, another along surface, opposite direction of P. तो ये F और Fs equal है. That is why there is no acceleration in horizontal direction. R is equal to mg होगा. That is why there is no acceleration in vertical direction also. But when we increase this force, when we increase the force on the block, then what happens? You may make notes by pausing the video. हमने इस फोर्स को बढ़ाया. अब लेंथ ऑफ एरो हैज इंक्रीज. Force has been increased. Mg acting downward, and normal the reaction force P further get inclined away. And again we can do two components like this. Away. This is R or N, and this is Fs. In this condition, this angle theta is such that a block is just ready to move. Block is just ready to move, and in this case, this Fs, when the block is just ready to move. So Fs here is called maximum static friction. This Fs, and angle theta here is called angle of friction. This topic will help you to understand other topics in rotational motion. But if it start moving, then what will happen? This Fs will get converted into kinetic friction, and applied force may become reduced. It will get reduced. Here mg downward, reactionary force, this angle theta may decrease because force of friction will be less than the static friction. Now it will be kinetic friction, and this Fk less than Fs होगा slightly. So angle of friction is that when we apply force on block to move it from left to right, and the block just ready to move, if we slight increase in F make the block move, then this angle at which the reactionary force get inclined away from vertical direction is called angle of friction. I think it will be very clear to you. What I told you, I am repeating again. ये block है यहाँ पर. This is block. Its weight mj downward, P upward, reactionary force upward. Line of action has been shown different because to understand some clarity, they are different. Now when you apply small force, reactionary force get inclined away from vertical. This reactionary force has two components R and Fs. Fs the force of static friction, R is the normal reaction. We sometimes write it as N. Now if we increase F further, then reactionary force P further increase, get inclined away from vertical. And here the block may be ready just to move. In that condition, this Fs static friction will be maximum. And this angle from which the give the inclination of reactionary force from vertical is called here angle of friction. And further, if it start moving, then friction between block and surface become kinetic friction, which will be less than our static friction, limiting value. Force of static friction is very important to remember that static force of friction varies from 0 to certain maximum value. इसकी कोई constant value नहीं होती, maximum तो होती है, which is called limiting friction. In next video, I will take here laws of friction, which is very important. Thank you.